Hi and welcome back everyone to yet another lesson in the Python short course. Today in lesson 5 we'll be covering Python functions, and during our practical demonstration we're going to do a few examples of working with functions in Python. Now with that said, let's have a look at the objectives for today's lesson. First we'll start off by defining what exactly Python functions are. Then we'll move on to our usual practical demonstration where we'll actually make use of Python functions. So what exactly are Python functions? Well, in a nutshell, Python functions are simply just blocks of code. However, these blocks of code must be invoked. They differ from if-else statements or the regular code that we've been writing in that once you've defined or created a Python function, the code will not run until it is invoked, or otherwise known as being called. A Python function may or may not return data. In the event that data is being returned, we can use that data for further computation. We'll have a look at an example in our practical demonstration. And lastly, Python functions may or may not accept parameters. In most cases, when you do write complex algorithms, you're likely to include parameters as part of your function. Now, there are several reasons as to why developers would include the use of functions in their code. The first is for code decomposition, code reusability, as well as extensibility. Now what we have over here is an example of the function syntax. First we start off with the keyword def, otherwise known as define or definition. We then give the function a name. We provide any parameters if the function requires parameters to do its computation, followed by the executable statements. In the event that we want to return some sort of data, we can simply add the return followed by the data that we'd like to return. And here is an actual example of a function and not just the syntax. Once again, we start off with the def keyword or definition or define. We then provide a name and give it a parameter. In the case of this function, the name is greeting and the parameter required for this function to work is name. We then perform some sort of computation, and all we do here is simply just print the keyword hello concatenated with the parameter name. We then invoke or call the function greeting and pass the keyword or name Steve, and the result is hello Steve. Note that in this function we do not return any sort of data for further computation. This function simply just prints the statement hello Steve. To better understand the concept of working with functions, I think it's time that we dive right into our practical demonstration. So without further ado, let's start scripting. Now, once you've booted up your PyCharm environment and you've created a new project structure, we can get started with scripting. So I'll start off with a simple comment over here called greeting, and I'll say function, just so that if any other developer picks up the script, they know exactly what it is that we are trying to achieve. I'll then start off by building or defining my function. So def, I'll give this function a name called greeting. I'll then specify that this function does indeed take a parameter called name. So the parameter over here is much like a variable, if you will, that we'll use at a later stage. I'll end this off with a colon, and we want to make sure that we're also using indentation with functions, much like we did with if-else statements. And I'm simply going to do a print statement that says hello. We need to wrap this in a string. So I'll say hello, give it a bit of space. I'll concatenate this with name, and then I'll concatenate this with another string that says how are you doing? Now let's review this function for a second. So we've created a function, we've given this function a parameter of name. We then simply print out a string concatenated with whatever the user is going to pass in as name. So the important part to take note of here is that whatever value the user passes in here, that's going to be used over here in our statement. So let's actually demonstrate this. Keep in mind that with functions, we need to invoke them or call them. If I simply run this code as is, nothing is going to happen because I haven't invoked or called this function. So on a new line, I'll remove the indentation and I'll say greeting, and then I'll pass in a name like Alexis. And now if I run this code, you'll see I receive an output that says, hello Alexis, how are you doing? So if I just put this on a new line for a second, the function is being called or invoked, and the parameter that I'm passing in is a string. One way to think of functions, one way that I like to think of functions in a simplified fashion, is that functions are instructions to do some sort of computation. Think about baking a cake, for example. Sometimes you have the recipe and you need ingredients, and there's certain steps that need to be carried out. In the case of functions, this might be the recipe, the parameters might be the ingredients, and this might be the steps that are carried out for the function to do its work. And of course, greeting in this case could be the name of the recipe. So that's one simplified way to think about functions. So if I changed Alexis to John over here, we should receive an output that says, hello John, how are you doing? Let's actually validate this. And if I run this now, I receive a message that says, hello John, how are you doing? Excellent. So let's remove all of this and let's create a function with arithmetic operations. So I'll say calculating the area of a rectangle. Great. So if you'd like, you could simply run a search on Google to figure out what this looks like. And here is the formula for determining the area of a rectangle. The area is equal to the width multiplied by the length. Great. So let's try to extrapolate that and create a function. So I'll once again create the function, and I'll give this a name of calculate underscore area, RECT for rectangle. And then I'll add the parameters over here, length as well as width, and then colon on a new line. Again, indentation is important. I'm going to create an inner scope or a local scoped variable inside of this function. I'll explain what this means in a second. And I'll set this variable equal to the length multiplied by the width. And I'll simply just do a print statement at the bottom that says print the area. And again, we need to call this function. But before we call this function, let's just have a brief moment to discuss what exactly a local scoped variable is. What this means is that this variable area that I created inside the body of this function is only accessible within this function. There's no way for me to reach this variable outside of the scope of this function. So any computation that I'd like to do with area, I have to do it locally inside of the function. And in this case, I've created the variable called area. I set this equal to the result of length multiplied by the width, and then we simply print out the area. Great. So now we've got that out of the way. Let's calculate the area by calling this function. And note that this function takes in two parameters, length and width. So I'll provide the length over here. So we could go with something like 5. And the second parameter that I'm going to, or the second parameter or variable I'm going to provide here could be 10. And now if I calculate this, notice that I get 50. Now, if I change this to 3 and 15, the output should be 45. And that's exactly what it is. Wonderful. Let's do one more example, but instead of just doing some very basic functions, let's try to return some value in our function so that we can do additional computation with it. So here's the scenario. I'm going to create a function that is used to withdraw money from an ATM. That's the basic case study for this. So withdraw money function. I'll then define this function by saying withdraw money, which is the function name. And then I'll provide this with a parameter of amount. Close this off with a colon. And then on a new line with indentation, I'll create a new local scope variable called balance, which is equal to 1,000. In this case, you could say $1,000, for example. Then I'll create another variable called current underscore balance, is equal to the balance, which we created here at the top, less the amount. So the current balance will be the balance after we've done some sort of withdrawal of our money. The amount that we want to withdraw is going to be the amount parameter over here, and this is the current balance that we have in our ATM or our bank account. Then I'm simply going to return the current balance, and this is perfectly valid because this is still within the scope of this block over here. So I can return the current balance because the return is within the scope of this block. So what will happen is that we can return the balance and we can perform some sort of computation with that value that we are returning. This is what the return statement means basically. It means return some sort of data so that I can do additional work. And what I'll do now is, on a separate line, I'll do a simple print statement and I'll copy and paste what I already have. So I'll copy the string that I'm going to add. After your withdrawal, you have $, and let's concatenate this with the string function because we are going to convert the current balance amount, or we are going to convert whatever this function returns, which is the current balance, and pass it in over here. So then within my parentheses over here, I'm going to call the function, and this too is perfectly valid. We can call a function within another function, in this case, the string conversion function. So this does require a parameter, as you'll notice here, and I'll pass in a value like 450, and then I'll simply concatenate this with another string called remaining. Also note that the reason we call the string conversion here is because we are concatenating a string on this side and a string on this side with a number, and therefore we have to convert the integer into a string. Great. So what can we expect to happen? At the end of the day, we are going to retrieve the current balance after withdrawing 450 from the initial balance, and that should give us an amount of $550. So if we run this code, you'll notice that after your withdrawal, you have $550 remaining. Great. Now, what if I wanted to change this around? If I decided to add a completely different value over here, like 900, I can expect to see $100 remaining in my account. And that's exactly the output we receive at the bottom of here. So this is basically how functions work. Functions work on the idea that you want to perform some sort of computation in a block of code. And why they are so useful is the fact that we can call them over and over and over and over. And this refers to code reusability, which means we don't have to go and write out this piece of code statically every single time. Now that we have a function that stores all this computation, it's easily available and accessible within the scope of our entire script. And that is it for functions. You can also go and try this in the cloud platform program iz.com. This should work perfectly fine. Feel free to do so. In fact, I encourage you to challenge yourself by refactoring all of this code simply by adding an if-else statement. And this implies that if the balance is exceeded when we withdraw too much money, then we should get a different output if the opposite occurs. This does require a bit of thinking, but it's entirely possible. And do keep in mind that challenging yourself and trying new things only reinforces the learning process. Now, that is it for today's lesson. And what we've achieved was working with functions, creating functions that accept parameters and also return some sort of value. In our next lesson, we are going to work with loops in Python, and loops can be a bit tricky, especially for beginners, but we'll start with the very basics. So for all of that and more, I'll see you in the next lesson. Cheers.